The heat. So you think it's the heat? You think this one's the least? You change your mind?
Watch me change my mind. I was gonna be like,
okay, so you say heat.
I'll go with this one.
And you said, and why do you think that's gonna get the least?
When you said that, what was it that attached to the air pocket?
Yeah, like
yeah, because it's like gonna be stale. It's not gonna like fizz or whatever.
It's gonna have less fizz.
It's gonna have it. Yeah.
Yeah. So which one? So let's do ones that we think are gonna be the least one. So I'm gonna put 2 in this one, and this is so that just in case it fills. So this is the relatively non-fizzy. It was still open only 20 minutes ago. So let's see what happens. Nothing. Nothing, right? It sucks. A little bit. There's like, if you look, there's a little bit. But just think about that. The 20 minutes that it was open made a big difference in the big explosion. Okay, so which one is next? Which one do you think is going to be the least? No, the next least. Next least. This one? Because of the increased heat?
Yeah, I think it is.
Heat. Alright, let's try.
The heat makes me lose.
Yeah. Okay, and you know what, honestly? I've never tried a heated can of Coke and Mentos. It might explode. So let's just be prepared, just in case. I'm gonna put 2. Just
Prepared for an explosion.
I'm gonna have 2. We're gonna keep it 2. Okay?
Oh yeah.
Exactly.
Exothermic reaction
Alright, ready?
is a Lewis reaction. And an endothermic reaction is when heat is.
Oh, we're wrong.
Look at that.
No.
We lost one. What's this from? It's from earlier? Is this yours, Kathy?
Yeah, go ahead, use it.
So, big difference, right? Big difference, eh?
Frozen one because no, it's like
Oh,
One of the
yeah.
reasons why we don't use
Yeah.
aluminum.
Now do we see?
It's like when it's heated up, it sounds like faster.
Let's just think about chemical reactions we hear all the time. What does heat usually do to molecules?
You're gonna want to try that.
Yeah, makes them more excited. Yeah, makes them more excited, right? The colder they get. Think about how when you're cold, if you get slower, like if you're cold, as opposed to when you're hot and you're up and you're doing something, right? So these were ready to explode.
Yeah.
Big difference. So these are almost the same because they're both frozen. But
I think this one's good.
this one might be a little colder, slightly, but they're both. So maybe we'll just do one more. They're both pretty cold. So this is usually the standard can of Coke. Standard can of Coke. We're gonna see what the difference is. This is cold. This was warm. So we'll see if there's a difference at all, and what it can be. All right. I think about what we just talked about, you know, what cold does to our molecules. All right. Here we go. So reaction, but not nearly as much, eh?
Like it had just as much pretty much.
Well, obviously, in any one of them, they're going to have the same amount because they're all made of the same thing. This one, of course, was just way bigger. All right. So, and this is the same. It's going to have the same reaction as this one. Might as well not waste. Okay.
Put it in our mouth and then drink some.
If you want, you can have both of these, but there's Mentos in it. You want to try it?
Well, actually, I don't like diet, but
All right, then.
diet.
Okay, so what did we figure out?
That the warm one was the most reactive.
Yeah, so before that,
Yeah. You don't want to add anything? And Why was the least reactive one?
Because it was sitting for a long time, so it kind of just like you got lazy.
Yeah. Lazy. That's true. They just get lazy, they just disappear right into the air. So the total summary of this experiment was that conditions affect chemical reactions a lot. Temperature, what else is a factor? And just a general sense of reactions. Other than temperature. Any other ones standing up? What was this one? Just like makeup. Like what is time? Yeah, time alters all things. Exposure to not just air, sunlight, that kind of. What else can be exposed to? Chemicals.
Or you could add like more sugar.
That's another thing. Diet doesn't have sugar. It has aspartame, which is more reactive than regular. That's why I chose diet. Sugar does react. I'm sure you've done it with regular. But aspartame, and the reason they have aspartame is because they want less calories and no sugar. So that's why we go with diet. So again, content of whatever it is that's reacting. It's not as good as regular. And so what other reactions happen in the outside world you can think of? What about that is a reaction. And what's that caused by? I think just when they touch their saliva.
Maybe it might be water, like just
yeah, liquid. But like, what about fire? And rust. There's a lot of conditions that affect rust. You don't see rust everywhere, and you don't see fires everywhere, right? That's basically it. Any questions about the experiment or chemical reactions or anything like that? Yeah. You can have the ones that open. Go on.